The local maximum does not include either of our endpoints. Okay? The absolute maximum can include endpoints, but the local maximum cannot. Okay? So if we're looking at this function here, we're going to do several things. First of all, where is the function increasing? So I'm going to go in and I'm going to identify where it's increasing. So I see an increasing here. I also see it increasing from here to here. And I also see it increasing from here to here. Okay? Remember, we want to write this in interval notation. All of this is within our line, and then we have a solid point at the end here, which means that all of these parts are included. So this here, we're increasing from -1, -2, -3, -4. Okay, so we're increasing from -4 included to, it increases all the way up to -3. Okay. We're increasing from +1 to, increases all the way to here, which is +5. And finally, we're increasing from 5, 6, 7, 8, all the way to 10, 11, 12, 8 to 12. Okay, so these are all of my increasing sections of the graph. Okay, now let's look at decreasing. Decreasing is where it's going down. Okay, so I see that it goes down from here to here. Okay, it goes down from here to here, and it goes down from here to here. Okay, so I have also three intervals for decreasing. This one is -5, -6, -7, -7 to -4, from 0 to 1, and then from 5 to 8. Okay, so those are my decreasing portions. Now I need to look for where the function is constant. There's only one spot where it's constant, and that's right here, from, looks like 1, 2, 3, -3 to 0. Okay, so we're just identifying each of the intervals where we see increasing, decreasing, and constant behavior of the function. Okay, all right, now let's look for these maximums and minimums. Okay, now the first part says we're going to look for where the maximums are. Now our absolute maximum is our highest point out of all of the points. Okay, now if I'm looking, my highest point out of all of the points is right here at 7, it looks like. Okay, so it's at 5, 7. Okay, or I can say at y equals 7. This is my maximum point, my absolute maximum. Now, my local maximum does not include my endpoints, so I have to look not at this point and not at this point. Okay, of these points in between, which one's the highest? Again, it's the same. We're at 5, 7, or y equals 7. Okay. All right. Now minimums. Okay. Let's take a look here. My absolute minimum, the lowest point of any point on the graph of my y values, is -3, and that's -4. It's at -4, -3, or whoops, y equals -3. No parenthesis there. Sorry about that. Okay. My local minimum, again, not including my endpoints, is the same point, actually, again. So -4, -3, or y equals -3. Okay. Now, it doesn't always work out this way, but in this case, my absolute maximum and my local maximum were the same, and my absolute minimum and my local minimum were the same. Okay, so let's go into the next page here. Okay. Increasing, decreasing, constant. Okay, so if I'm looking at increasing, and if you want to pause the video, you can pause the video and see if you can figure this out independently. Okay, and then come right back. Okay, so increasing, I'm increasing here from 1 to 2. 1 to 2. It's the only spot I'm increasing. I'm decreasing here and here. So here I'm decreasing from 1, 2, 3, 4, negative 4 to 0. And then from 2 to, oh, I see this arrow here. This arrow tells me, whoops, this arrow tells me that it goes to infinity. Okay. Now, where's my function constant? Looks like I'm constant here, and I'm constant here. So from 1, 2, 3, 4, 5, negative 5 to negative 4. And then also, looks like from 0 to 1. Okay. All right, now let's talk maximum and minimum. Okay, we're going to talk about maximum first. Looking here, where is my absolute maximum? Remember, absolute maximum can be an endpoint. Okay, absolute maximum is at 3. And so we'll say y equals 3. That's our absolute maximum. Okay. My local maximum. So remember, that's out for my maximum. Endpoints are out for my locals. Okay. So looking at the rest of this, what's the highest point? Now in this case, we see that there's another y equals 3 right here. It's a different point. So that one we can use as my local maximum because it's not the endpoint, it's a different point. Okay. How about my minimum? Now, in this case, my absolute minimum, the absolutely lowest point, is a negative infinity, right? Now, is negative infinity a point? Can we call that a point? Okay, so my lowest point then, my absolute minimum is negative infinity, but negative infinity is not a point. So if we're looking for our lowest point, we have a negative 1, whoops, y equals negative 1. And my local minimum, again, my endpoints are out, is also at negative 1. Okay. All right, next one here. Go ahead and take a second to pause the video and find these, and then you can turn it back on. Okay. Okay, increasing. I see that I'm increasing from here to here, so from 5 to 6. I also see, let's see, I'm decreasing. Now this one's kind of tricky. I have a point here in the middle, but essentially I'm decreasing all the way from 0. So I'm decreasing from 0 to 3, and then from 3 to 5. Now, if I'm decreasing this whole section, even if there's a point in the middle, I'm going to write that as one interval from 0 to 5 because that whole part is decreasing. Okay? Now my constant is from 6 to 10. We're constant from 6 to 10. All right, next part, maximums and minimums. Now, my absolute maximum is the absolutely highest point on the graph. It can be an endpoint. I see that my highest point on the graph is y equals 5. Okay. Now, my local maximum cannot be the endpoints. Okay. So, my local maximum is one of these points here in between, and I see that my highest point is at y equals 2. Okay. Now let's talk minimums. All right, so my absolute minimum, the absolutely lowest point on the graph, is right here. Y equals -2. And my local minimum, again, we cannot include the endpoints. My local minimum is also y equals -2. Okay. Alrighty. So, starting just with this for today, your standard practice, you can do page 104 for the practice, okay? And then tomorrow, we will talk about determining even and odd functions, okay? Sound good? Alrighty, everybody. I'm headed off tonight to a costume contest for the conference. I will be dressed in my pumpkin pie costume, so I'm hoping to win. So for your exit card today, please write down where I'm going tonight, costume contest, and what I'm hoping to do, win the costume contest, okay? Everybody have a happy Halloween. Please stay safe tonight. Whatever you're doing, stay safe. And I'll see you tomorrow. Okay, bye.